Hello again, everybody. In today's lesson, we're going to be looking at a lot of terminology that has to do with collecting survey answers to survey questions. Um, so there will be a little bit of math, but most of it is just going through some of the terminology that you might hear when you're talking about surveying to get information. So the title is Sampling Techniques. When conducting surveys, many things have to be taken into account. Let's look at some of the terminology needed to understand this section. So, population. The definition for population is all individuals or items that belong to a group being studied. There are 250 mathematics students in our school this year. 250 is the population of these students for the survey. So if we wanted to survey all of the math students in the school, we would say that the population size is 250. What is a sample? A sample is a group of individuals or items that are representative of the population from which they are taken. So here's an example of that. Quality control will test 20 of the 200 boxes of cereal coming off the conveyor to check to see if they have the correct weight. 20 is the sample. I just realized I made a spelling mistake here, so I'm just going to put another F right there. So even though this isn't asking questions, you can have a survey, if you will, of items to see if they meet quality control. So it's kind of a similar idea. You can have a sample size to see how many of them match, and you then have a fairly good idea as to what the entire population of those boxes in this case is like. So this terminology can be used in different scenarios like that. Sampling methods. So I'm just going to pull the shade down here so I don't reveal everything at the same time. So there are different sampling methods that can be used to gather information. One of the ones you'll see very often is a simple random sample. So in a simple random sample, each member of the population has an equal chance of being chosen. So let's say there was a survey being done in Sudbury. They would randomly generate a list of, let's say, everybody's addresses and pick a certain amount of people. They wouldn't pick the entire population of Sudbury to send the survey to. They would pick a certain amount of people. And that would be a simple random sample. A stratified random sample. The population is divided into subgroups. So example, gender, age, etc. And a random sample is selected from each of those subgroups in proportion to its size in the population. So for instance, there are 500 girls and 400 boys in the school. Dividing each group by 50, a committee chooses to randomly ask 10 girls and 8 boys. So you'll notice that there's less boys being asked compared to girls because there are slightly more girls than boys. Proportionally, the 8 boys represents the 400 and the 10 girls represents the 500. So that's what a stratified random sample looks like. What about a voluntary response sample? Well, only those who choose to answer the survey are chosen. So you could send out a survey over Facebook, let's say, and only a few people would actually volunteer to answer it. That would be an example of a voluntary response sample. A cluster sample. After dividing a population into clusters or groups, only certain clusters are chosen. Now I'm going to show some graphics of what I mean by some of these because they're a little bit difficult to discuss and explain without those graphics, but that's coming up. Convenience sample. So contains members of the population that are most easily asked to take part. A systematic sample. Every nth member of the population is selected. So you could have a list of everybody's addresses and say we're going to ask every 5th person on the list, counting from the beginning of the list. So as I said, I have some examples of this that I got from a web page. So I just did a search for different sampling methods, and I came onto this webpage. Now they have examples of some of the different sampling methods that we've already talked about, but they also have some other ones too. But what's interesting is they actually have graphics to show some of them. So here's a graphic of a population versus a sample. So this is the entire population, and a slight a group of that entire population is called the sample. So what are the different sampling methods? Simple random sample. So here people are chosen randomly. Here's a systematic sample, where every third person is chosen after you select the first person. The first person doesn't have to be the very first person on the list. You can start it anywhere. But the idea here is that every third person on the list is asked. They have the definitions here as well. So here's a stratified sample where you've divided up the groups into, in this case, it would be like, let's say, male and female, and proportionally the same amount of people are chosen with respect to the size of the group. So if you look here, there's 2, 4, 5, 6, 7, 8, 9 of the blue, the dark blue. 9 divided by 3 would be 3 of those people. Here there are 6 of the light blue. 6 divided by 3 would be 2 of that group. So that's how a stratified sample works. A cluster sample is when you divide up a population, and it could be a randomly distributed population, but you divide them up into equal group sizes, and then you just pick a certain number of those groups to represent the entire population. There are others down here. Here's an idea of a convenient sample where a person is closest to, let's say, the immediate members of the family or the closest friends, and those are the people that are chosen to answer. A voluntary sample, you'll notice that the arrows might be a little bit hard to see, but the arrows actually all point to that one person in this case, and that's because those are volunteers that are choosing to answer the survey. And there's a couple here that we actually didn't talk about. So this website right here, and there are others you can go to find information if you need to about those different types of sampling techniques. Okay, so here's a mathematical example. There are 300 students taking mathematics this semester at Royal Secondary School. The table shows the number of mathematics students in each grade. So there are 100 grade 9s, 80 grade 10s, 75 grade 11s, and 45 grade 12s, which is a total of 300. Miss Barron, the principal, wishes to survey a total of 60 math students. She has chosen 20 grade 9s out of the 100, 16 grade 10s, 15 grade 11s, and 9 grade 12s. So what is the percent of the population that each grade represents? So let's start by looking at that. So if we want to know a percent of the entire population, the way a percentage is calculated is always by taking the number that we're interested in, dividing it by the total number, and then multiplying by 100. So for the grade 9s, we would have 100 divided by 300, which is 1/3, which is 0.33, and then we would multiply that times 100 to find the percentage. So there are 33% of the entire, the population of grade 9s represents 33% of the entire population. For the grade 10s, we have 80 out of 300. Now, both of these numbers are divisible by at least 10. So I'm going to do this in a slightly maybe longer way, just so that I don't have to think about it too much. I can probably do it faster by doing it rigorously like this. So that's 8 over 30. Now, both of those numbers are divisible by at least 2. And that gives 4 over 15. And I believe that's the last and simplest fraction that I can get it down to. Now, if I switch over to the calculator here, let me just clear this entry. So we've got 4 divided by 15. That gives 0.26 or 0.27 if I round it off. So 0.27, and that would equal 27% of the population. For the grade 11s, we have 75 out of 300. And just to save a little bit of time, I'm not going to reduce the fraction, and I'm not going to show the calculation on the calculator. I'm just going to do the calculations off to the side. You can take a calculator out and do the division. And what we're getting with this one is 0.25, which is 25% of the population. And for the grade 12s, I can't remember the number. It was 45 out of 300. Again, if I do the calculation off to the side, that gives 0.15, and that gives 15% of the population. So our grade 9s represent 33% of the population, our grade 10s 27% of the population, our grade 11s 25% of the population, and our grade 12s 15% of the population. Now, where we're heading with this, did Miss Barron choose an appropriate amount of each grade to represent the entire population? As the grade 9s, there's more students in grade 9 than there is in grade 12, you would think that you would ask more grade 9s than you would ask grade 12s if you want a correct distribution of the people representing each grade. Okay, so that's what the next question asks. Calculate the percent of each sample. Calculate the percent of each sample that each sample represents from the total sample size. There's another spelling mistake here. Sorry about that. So calculate the percent that each sample represents from the total sample size. Well, what is our total sample size? We've got 20, 16, 15, and 9. Okay? 20 grade 9s, 16 grade 10s, 15 11s, and 9 grade 12s. So 20, 16, 15, and 9. So I'm going to write those here. And let's add up the total here. So 20 plus 16 is 36. 36 plus 15 is, so 36 plus 10 would be 46, plus another 5 would be 51, plus 9 would be 60. So our total is 60, okay? So for the grade 9s, and I believe I wrote that in order, so 9s are 20, 10s are 16, grade 11s are 15, and these are the grade 12s. So these are 9s, 10s, 11s, and 12s, okay? So if I asked 20 students out of 60 for the grade 9s, what would be my percentage? Well, this gives 1/3. If you reduce this, both of them are divisible by 10, both of them are actually divisible by 20. 20 divided by 20 is 1, and 60 divided by 20 is 3. So my answer is 0.33, which is 33%. And that's what we had gotten, if I'm not mistaken, for the total population of grade 9s, which was 33%. Now let's see if our sample size of students for grade 10 is going to be 27%. So 16 students out of 60. So both of these are divisible by I'm just trying to figure it out here. They're at least divisible by 2, which would give 8/30. and then they're divisible by 2 again, which would give 4 over 15. So we're getting a fraction of 4 over 15 for that one. Let's go back and look at the fraction from grade 10s up here. And if you look at that, the fraction is 4 over 15, which is 27%. So far, it looks like the principal or the teacher did ask the right percentage. So the next one is 15 out of 60. Now 15 goes into 30 twice. That means it has to go into 60 4 times. So I know that this fraction already has to be 1/4, and you can check that yourself by reducing it if you don't believe me, which is 25%. And again, if we go back, it is 25% for the grade 11s. And the last one is supposed to be 15%, so that's 9 out of 60. Both of these are divisible by 3. So, actually, let me write that underneath here. And using my calculator off to the side here, 3 divided by 20 is 15%, which is the correct answer for the 12s. Okay, so that is proof that whoever decided to survey each one of these groups did check to see, well, how many students in each group would you have to choose to keep the exact same proportion as for the entire population of 300 students. So these 60 students do follow the same proportion of each grade. Which is good. That's what it should do. Now it says, how could you randomly select students from each group? Well, there are a lot of different ways of randomly selecting students. I'm going to quickly show you one way that you could do this, and that's by using a spreadsheet. There are calculators that can do this as well, but using a spreadsheet sometimes is once you've learned how to use one properly, can really help to reduce the amount of work you have to do. So I'm just going to go to Google Sheets here, and I'm going to create a new sheet. So what we could do to pick 20 random people out of 100 is we could get the spreadsheet to generate for us a random number between 1 and 100, and then just get that to repeat itself 20 times. So how do you get a spreadsheet or anything to create random numbers? Well, there are formulas that you can write inside of a cell of a spreadsheet to get it to create random numbers, and that is usually rand as the operation. RAND stands for rand. Now we actually want to pick a number between 1 and 100 randomly, so there's another word that you can use, and that's rand between. Now I want you to see that I started this with an equal sign, and when I started to type, it actually started giving me suggestions as to what I wanted to get as a special word to create this random value. So rand between means a random number between two values. So I'm going to start typing rand between, and usually in a spreadsheet you open a bracket to say what are you picking from. So I want to pick a number between 1 and 100, so I'm going to put a comma between those two. And then I'm going to press enter, and as soon as I press enter, it's going to give me an answer. Now that answer is a random number that was chosen between 1 and 100. Now I could type that in for each cell but that would take a long time. What's nice about a spreadsheet is this little point in the corner here. You'll notice that when I put my cursor over top of it, that it actually changes from an arrow to a plus. And the reason that happens is because there's a special thing you can do with a spreadsheet where if you click on that button and drag down, I'm going to go all the way to the 20th cell. When you let go, it's just going to fill each one of those cells with that same equation or that same statement of random number between 1 and 100. So when I let go, I've now gotten a random distribution of numbers between 1 and 100. Now the only thing that's wrong, that could be wrong with this, is you'd have to check to see do any numbers repeat. And it's kind of hard to just see without listing them all in numerical order. So what we can now do is we can actually sort this list. Now you'll notice that it's already selected. Now if it wasn't selected, we could just select it again. And then you can go to data and you can say sort the range. There's different ways of sorting. You can sort the entire sheet, but we have a range selected. So we're going to sort the range by column A. Oh, it didn't do it for some reason. Okay, so the reason that's not working is because every time I sort the range, it actually picks a new combination of random numbers. So what we could do, and this is a little bit longer than I wanted to do, but I can just show you quickly. You can do something in a spreadsheet. You can copy, and then you can paste with a special statement saying paste only the values. So that way, I'll show you the difference. Let me make these a little bit bigger for you. If I click on this cell, it's still the expression that I used to find a random number here. But when I click on this cell, it just says 11. So it has actually transformed, and you'll notice that these numbers actually changed again. So we still have a random distribution, but this time they actually are considered numbers in the cell. So if I select all of these and go to data and then sort range, even though these numbers are changing, I actually don't even need these numbers anymore, so I'm just going to delete them. These are my range. Now you'll notice that one of them repeats, and I think it might be the only one. Yes, it's the only one. So, you know, you could just say, okay, well, let's make that a 2 or a 4 instead. So I'm just going to change it into a 4, and now out of the 100 students, I have, if I number them 1 to 100, I can pick these and know pretty well that these are random. Okay, so there are different techniques to picking random values. And I just wanted, and there are others. I mean, you could probably go online and find a random number generator, but you'd have to do it 20 times. On the spreadsheet, you can select a grouping and make sure that you know exactly how many of them are going to be random. If all of the students were numbered 1 to 300 and 60 random students were selected from that group, what problems might there be with this selection method? So I'm going to let you think about this one, but consider that if 60 random students were selected from the group, would we have an even proportional selection like we did in number 2? So I'm just going to leave that there. Okay. So another term that you might hear a lot when you're surveying is the word bias. If a survey is not representative of the entire population, it may not give results that can be trusted. So this can be caused by a bad sampling, the wording of some questions, the interpretation and presentation of the results. So for instance, here's one example. You sometimes will hear stuff like 1 in 5 dentists represent a certain brand of toothpaste. Well, 1 in 5 sounds like a pretty nice number, but how many dentists were actually surveyed? If only 5 dentists were surveyed, that is a biased result because the interpretation of the results isn't exactly fair. Okay, so here's an example of response bias. Parent council survey is conducted to learn if after-school music program should be offered. The survey question reads, early musical training helps develop brain areas involved in language and reasoning. Should the school offer an after-school music program? And then it says, why does this question, why might it result in a response bias? Well, if you read the question, right away in the question, it actually says, hey, this early musical training helps develop brains. Isn't that a great idea? Should we have the program? So it's leading the people reading the question to think that it's already a good idea because it's giving quote unquote proof that it is without really saying where that proof comes from. And it might kind of lean people to say, well, if I say no to this, I'm not really in favor of developing brain areas involving language and reasoning. So this is an example of a biased question. Rewrite the question to eliminate possible response biases. Could you do that? Could you rewrite this question so that you wouldn't have any more response bias? And I'm going to let you think about that. A couple more pieces of terminology that you need to know here. What is the difference between a primary source and a secondary source? So let me just hide the bottom part. We'll just look at them one at a time. So what is a primary source? A person who collects data for their own use. If you go to the mall and you stop 20 people at the mall and personally ask them questions, you're a primary source of data. Okay, you're the one who's gathering the data. You're asking the question. You are the primary source. The secondary source would be a database or research collected by someone else. So it could be found on the internet. It could come from a statistics website. That is considered secondary source because if somebody's getting this information, they're getting it from somebody else. Somebody else did all the work, asked the questions, collected the answers, and put them, on a sheet or something on the internet that you can download. That is a secondary source of information. I believe that is it for today. So today's lesson was a lot of terminology. I did show you a little bit of math in one of the examples. I will be posting some homework questions from your textbook on the Google Classroom, and I would ask that you try to complete as many of those questions as possible, and we'll probably be taking up those questions tomorrow in the lesson tomorrow. Have a great evening, folks. We will talk to you soon.